All right, everyone. Hello. Thanks for joining me today. Given that everybody can see my screen right now, I'm here to present with you today, building the built environment with Immersive Technologies. This is something I'm really passionate about, and I'm really excited to share with you guys today. So first off, a little bit about myself. So my name is Cody Nowak, the founder of Cube, which stands for Collaborative Ultimate Building Environment. And I'm coming to you live from downtown LA. It's a little overcast down here, but you can see that's no backdrop. That's actually downtown LA. So there's actually a few buildings that I've worked on in the background here that I've used immersive technology on for virtual reality and mixed reality. So actually getting the tools out in the trade, eating my own dog food in downtown LA here. So pretty exciting. If you'd like to reach out to me at Cody@BIMcube.com or on Twitter at DisruptAEC. All right, so let's jump right into it. I'm going to go through the spectrum of the different realities for those of you that are unfamiliar. But there is one reality everyone is familiar with, and that is real reality, RE. Right, so it's the reality we're in right now. It's the reality we're born into, that one-to-one human scale. It's what we all understand. It's the built environment that we build. It's the base of every reality from here on out. Next is augmented reality. So augmented reality / AR is a virtual content that's superimposed into maybe a smartphone or a tablet, and it's typical for our industry. It's contextual information overlaid in the built environment. So maybe we're getting some RFIs or some virtual 3D model, BIM modeling, if you will, that's just being overlaid in that environment. And then next, which I'm most passionate about, is mixed reality. Well, most excited about for up and coming technologies, or /MR. So these are technologies that are spatially aware and overlaying the virtual environment. And you're seeing real reality while the virtual content is being pinned in reality, and you can walk around that content and it stays pinned. And you're wearing some glasses, some visors that are head-mounted display, and it appears to be what we call holograms. So for short, for easy, just call it holograms. And that can be in a one-to-one human scale, or we could do a dollhouse where it's a scaled-down model where you're able to walk around and look at it. Next is virtual reality, so VR, also known as VR. And this is where you put on a headset that is the total virtual environment, right? So the built environment before it's built, that's what it's great for being used for. So you're not seeing any of real reality when you're in virtual reality. It's very immersive, and like I said, it's great for collaboration and experiencing the built environment before it's built. All right, so with that, I wanted to go over a few use cases for what VR, AR, and MR are great at, what they excel at, right? And then also their shortcomings at the same time. So we'll start with VR, virtual reality. Virtual reality is one device per user. So that would be a headset /HMD, so head-mounted display that one user puts on, and it's a very personal experience. So just one person's really getting that experience, unless there's some peripherals, maybe a computer screen or a TV, so other people standing around in the actual real environment are able to see what that person's seeing through their head-mounted display. Its environment is for indoors only. I have used it outdoors, but it's not exactly the best thing to have for, best technology for outdoors. You'll have hand controllers, right? So there is starting to be technology that's able to do hand reading, and that's up and coming. But for now, most of the readily available VR headsets that you can go out and buy at Best Buy or maybe online and Amazon, you're going to get some sort of hand controller that allows you to interface with the user interfaces that are in virtual reality, as well as interface with the actual environment as you're walking through. That experience, once again, is fully immersive. So you will be immersed fully in a one-to-one human scale, and it can go from real-time rendering where the content is pretty simple all the way up to a very high-polished, high-quality render that's maybe coming out of an Unreal Engine, and it can look really amazing and almost trick the user into thinking that they're in that actual environment. I suggest that real high-quality polish at when you're around 90% complete with construction documentation, and you want to interface with the owner or potential end users and allow them to experience the built environment, their product before it's actually built. That way, if there's any glaring issues right off the bat, they're going to catch that before you get into construction, and they'll really get that nice sense of immersion and what their environment will look like. All right, next up is AR/augmented reality. So users, this can be, multiple users. And again, this goes back to like, smart devices, tablets, handheld devices. It's good with, for environments indoor and outdoor. This is saying best outdoors, but it's really both indoors and outdoors. Maybe some of the viewers have kids on the stream today, and those kids have, or maybe the users have actually played the Pokemon Go app. This is a great example of a AR-like app. It will give you a better idea of maybe what AR is. I'm not sure that it's necessarily AR, but there is that sort of overlay of content and contextual information as you go through that environment. So, and that's, of course, can be indoors or outdoors. So if you use that as a base, think about using it for like wayfinding, going through a job site, overlaying the BIM content, contextual information like RFIs on the built environment. But there are issues with localization and being spatially aware with these devices. For now, in the near future, probably not. Again, so it's handheld or machine mounted. And the experience is interacting with the real world, like I suggested. So it's also another great way to share from field to office, office to field for communication. The thing about AR is it's readily available. Everybody has a smart device in their pocket. I'd be very surprised if there was anybody on this stream, anybody out in the field that did not have a smart device. And most of the smart devices are going to be AR capable. Moving on to MR/mixed reality. Again, this is user experience. It's a standalone headset for one user, right? But the thing is that you can get in and have multiple users experience the same content and be able to have the face-to-face experience with those headsets. They just sort of aggregate into the same environment because they're spatially aware. And what this allows is a much freer form of interaction between multiple users. It's good for indoors and outdoors, definitely better indoors because it needs to see the space around it to be spatially. It's creating these spaces that makes it spatially aware, and there's sensor fusion that's allowing it to do this magic sauce. So you need to have some walls and some ceilings and stuff around for it to really be effective. And the flexibility, it's for user interface is you're using your hands, through gestures, voice command. There's no controls that you need to use. So pretty exciting to see that up and coming in the new devices. And again, the experience is interacting with the real world. So that interaction, again, you'll want to have the contextual space around you to really have a good interaction. So for example, you could see the construction layout before it's actually placed or drawn out in the field, right? So, or you can just see what's going up from that construction layout as well. Again, great for field to office, office to field interaction. Of course, I want to point out you will need some sort of connectivity out in the field to get that real-time connectivity. All right, so first I want to start off with what a cube is, what I've been building. It's more of a shared virtual environment, and it's open to all the different realities within a room that's typically about 20 by 20 by about 13 feet tall, with movie screen walls where we're projecting onto the walls, and it's a group of people are able to be in that shared virtual environment, not have to wear the headsets, which is great in today's social distancing environment. So we're able to have a handful of people that are 6 feet apart, not touching anything, just standing in that virtual environment, sharing that space, and seeing a near one-to-one human scale 3D walkthrough of the built environment. So CUBE stands for Collaborative Ultimate Building Environment. Again, the hardware and software is versatile. So what I've done is open it up to where instead of having sort of a cave experience, the computer automatic virtual environment of just 3D content where it's one-to-one and you have 3D content jumping out at you. You're now able to throw Revit up on the wall or Forge or Unreal on one wall and have sort of a what we like to call a command center, Tony Stark style, where multiple people are seeing all this different content come through. So here's a couple of pictures that give you that idea of being immersed. Obviously, this top one is not a great example of social distancing. This was before social distancing came in, but you get the idea. There's plenty of space in there for those guys to social distance. And what it's showing is a newbie to VR that's never been in VR, putting on the headset, and then the guy on the left in the white shirt is showing the guy through that virtual environment. And then everyone else is now seeing that virtual environment in a large scale. So very good for interaction between teams to understand it. Now VR becomes a team tool where everyone is on board and seeing exactly what's going on instead of just staring at a guy looking all over the place in a VR headset. And then the next image down is a guy that's, so this is a senior architect walking up to the wall and interacting with Revit, which he would never interact with a BIM tool. Just because that's, he's design architect and he pushes all the construction document creation and drafting, 3D model making off to the other teams to actually do this. But the thing that he does understand is that construction documentation, those floor plans that he's going up and you can see touching and selecting and then driving the actual collaboration meeting in a tool that he would never be capable of doing that. Also, the point of the cube of being so flexible is that teams can use the tools of the trades, such as Struction Site, Revit I already mentioned, Unreal Engine, Fuser, you name it. If it's in Windows 10, you're going to be able to pull it up in this huge 40-foot screen. It's like the IMAX for the construction job, the construction project. And if they know how to use it, they're going to be able to grab the mouse and keyboard and go to town, which is really good because the problem with VR and AR and mixed reality is there's this learning curve that the end users have to jump in. They may know their project, they may know the content that's there, but they don't know the interaction. But typically they'll know the interaction of something like using a mouse and a keyboard. And if they get that interaction, it's going to be conducive to the coordination meetings to just flow and go very quickly, and everyone's actually seeing things at scale, what's going on out in the construction site in real time, whether that cube's just off the construction site or in an office somewhere else. So very powerful tool. And with that, I'm going to show you a quick video that really describes one of my clients up in Seattle, McDonald Miller, that we're able to get this cube up and running a couple years ago, and they haven't looked back since. Gives a great example of what we're building here. There should be audio. Joseph, can you hear audio over there?
I can't hear anything.
Okay, I'll just talk over it. So what you're seeing, so renamed BIM, but this is BIMcube. So being able to experience that virtual environment before it's built, again, going back over what I said, but this gives that visual of what the teams are seeing, right? So we built this for the specific use case of project acquisition, and then after that acquisition, getting the teams into the cube out there at their office, and allowing the teams to go through and coordinate and utilize the BIM models that already been created in the different BIM tools, and be able to experience it in VR, bring in the owners, bring in the end users, the decision makers, and get them in that virtual environment in real time. Also, that's a big deal, is that real-time rendering, real-time walkthrough, where you don't have to do the big polish, like I was talking about, that 90% at, when you're about 90% in construction documentation, it doesn't need to have that high polish. Since we don't have sound, I'm going to jump on to the next slide. All right, so jumping into virtual reality in AEC. So virtual reality is it's more mature than any of the other technologies we've covered so far that we've discussed. So it's a headset that is, as you can see in these pictures, you put it on, you're totally immersed in that one-to-one human scale in a virtual environment. It's a very personal experience. However, since it is so mature, it is a much higher quality render of the content. Can be, it really depends on how much time you put into rendering out that content. So if you have a company like Unreal using Epic's Unreal Engine, that is some of the highest quality rendered content that you can actually show. In I think Greg has his hand raised. Are we taking questions now, Joseph? Or?
The questions will be left until after the presentation. So
all right, great, thanks.
Later. Yep.
All right, moving on. So yeah, again, so getting that high quality rendered content in is you're going to have to put some time in, and we'll go over the different types here. So virtual reality. So there's multiple headsets that are readily available today. You can go to Best Buy or buy on Amazon. And there's a couple of examples here. So one is the outside in tracking. So over here on the left, we have two base stations, the hand controllers, and the headset. So those two squares are actually outside of that user that has the headset on, looking in, tracking that user through the sensors that you see these little indents all over that headset on the left. So as that user's moving around in about a 3 by 3 meters squared environment, and taking one step in reality, it's equal to one step in virtual reality, they're being tracked. And it's highly accurate, and it's tethered to a VR PC. So VR PC means virtual reality personal computer that's capable of running these high quality headsets, right? These professional grade headsets. So, we're using these types of headsets in the cubes. We're using them in the office where you want to be able to see bigger models, higher quality rendered content. But now there's also other headsets that are less expensive. They're not at the, about $1,500 price point for just the headset. And then you got to tack on that VR PC price, which is typically a couple $1,000s. So it gets pretty expensive pretty quickly. But now there's new headsets out that are inside out tracking, like what we have over here on the right. And those don't require the the outside trackers. Those don't require a VR PC. It doesn't need to be tethered, meaning the connection going into the actual PC. So it's a standalone computer essentially that you're wearing on your head. And there's quite a few new softwares in our industry allowing us to view very large models on these smaller headsets, making it the price point to entry is much easier. I think it's somewhere around $500. But then you got to get your software that's capable of pushing that content. It's really where's your price point? What are you trying to do? The right tool for the right project. So one of the types of VR that is becoming more popular is VR co-presence. So meaning you can have multiple people in the same virtual environment with multiple headsets, VR headsets, and share that virtual environment and have a collaboration meeting. I've seen this happen, the uptick in this during the pandemic and everybody being locked in at home instead of going into the office. So you'll have multiple avatars walking around that virtual environment. And like you see over here on the left-hand side, and they'll have the name above their heads, but they might not look like that person. Kind of weird if you've ever been through it before. But then, again, you can do that remote co-presence. So each one of those avatars can be remote from home, or they can be in person, or like over here on the right-hand side. You just have to have multiple PCs, one PC per headset, to experience that co-presence if you're in person, or if you have that inside out, you just inside out headset, you all just put on that headset and you're able to jump into that shared co-presence VR. So one of the big deals that I really want to share is this has been building up over the past few years, is real-time rendering with bidirectional linking. So if you see in this animation, we're moving doors, and in real time in 3D, this is kind of funny, moving a grill over, you'll see over in the plan in Revit, it updates in real time. So syncing it back, and it moves. So which is a really big deal. We'll play that one more time. So you'll see over on the right-hand side, selecting the wall, it goes to Revit, placing a door, and then right away in that real-time rendered environment, you see that door pop up. So that means you're in the software making the changes, and you see it in virtual reality. Those capabilities have only come up over the past few years, and it's pretty exciting because now you're actually doing collaboration in real time with these technologies, and makes it so much more robust and capable and valuable at its price point. All right, moving on to augmented reality and AEC. So augmented reality, again, is where you have the smart devices, your smartphone, your tablets in your hand, being handheld, and you're overlaying the virtual information, virtual 3D model, and you see it on your screen. So a good example of this is down at the Apple Store in Silicon Valley. That's where this is at. I've actually seen it in person. It's really awesome. This is actually in an Apple Store by the Infinite Loop one, whatever they're calling it. They're at the Apple campus, and you have a 3D model that's been 3D printed or CNC'd out, just huge model of their actual campus. Is right across the street, but you're able to grab these iPads and walk around and go through different design options and see the different abilities of the different systems, like the cooling of the entire building, the different campuses around the building. So a great use of the AR to show, one, the product, of course, but then two, their actual built environment that they're really proud of, which is really an amazing project, and being able to share it with the public that's not able to see it. So if they get this interaction, now they're understanding what the built environment is. And this is to the end user, right? This is to the everyday customer that maybe has no idea about architecture. And then again, everyone has these devices in their pockets now. So the capabilities of getting out the experience, the augmented reality experience to multiple users is there. It's real. It's the most readily available form of augmented reality today. And it's going to be the most widespread for the near term until some of these other headsets slim down and become less expensive. All right, so moving on to mixed reality, some of my favorite new technologies that I've been working on over the past few years. I actually have a couple of the Microsoft HoloLens 1. I don't know if you guys could see it, and then Microsoft HoloLens 2 right here. So if you couldn't see those, down over here in the left-hand corner is the Microsoft HoloLens 2, and right next to it in the center is the Microsoft HoloLens 1. And it's an update to the obviously to the Microsoft HoloLens 1. Up over here in the right-hand corner is an example of a hard hat that has integrated, actually built in the Microsoft HoloLens 2 to a PPE hard hat that's actually certified for a construction job site. And you can wear that out there on the job site, and you should get no static or anything. Oops, go back. Hold on a second. All right, so there's, I want to point out there's only a few of these mixed reality MR devices that are capable, and they're not even readily available to the consumer base. It's mainly enterprise at this point. Down in the right-hand corner is actually what they call the Magic Leap. But in my opinion right now, the HoloLens 2 is really the exciting technology, mixed reality technology out there. All these devices are spatially aware, which means they're scanning an environment and understanding within a few seconds where they are in an environment. If they've been in that environment before, maybe the environment was scanned and provided by another device. But once they lock on, they know where they're at. They're able to bring up previous content. So maybe it's the BIM overlay. It gets it in generalized location. There's still some bugs, or not so much bugs. It's the device, the limits of the technology that are actually in the device. So that would be the sensor fusion, all these different sensors like stereo cameras, gyroscopes, infrared cameras that are spraying the environment with lasers and then picking up what those lasers are scanning. So if you could imagine like a sheet where you throw it up in the environment, or, in your living room with your kids, whatever, and then it drapes down around like your coffee table and your couch. That's what these lasers are doing. So you can read the features that are in that actual environment. And this goes back to making that just part of it, making the device spatially aware. All right, let's see if I have a video on the Microsoft HoloLens 2. It's kind of a sizzle video. Hopefully the audio works this time. Doesn't look like it's going to work. All right, so unfortunately, it looks like our audio is not working in this presentation. So good graphics, though. Hopefully it's not too choppy for you guys over there. You get a good idea of what we're capable of doing with the HoloLens 2. Some of it is eye candy, meaning what you're seeing is not exactly what is capable. So here they're showing sort of that augmented reality where you have your tablets that are capable of doing, overlaying the 3D content, but then this is the next generation, the next steps of mixed reality, right? So you can have it in your boardroom, office room, and see that content on the table like this, shrink down the model to a scale that's appropriate, and then scale it up if you want to zoom into a certain location. Go through different design options, Really powerful stuff, because before you had to go to a computer screen or a projector in order to see this, and it wasn't as immersive or as intuitive to be able to go through some of this information. Being able to look at the construction schedule on the fly and then apply it through mixed reality is pretty powerful as well. All right, we'll move on from that. Here's a good example of, and this is just more of a proof of concept, and it doesn't look like the audio is working on this either. But this guy's going through with a HoloLens 1 and placing RFIs coming from a construction management software. And he's actually out on the job site. So this guy comes through and he's looking at the RFIs that have been placed spatially around the job site. And now he's going to reply to that RFI. So I'm not aware of any mixed reality out there that's at scale to go across construction sites at this point, but this is where we could be in the near future. I'm sure there's companies out there working on this kind of content, but it's pretty exciting because you can imagine overlaying your content from your construction management software and being able to instantly know where the reference points are in the spatial environment. In comparison to having to know how to read construction documentation and the information and figure out where it is in the spatial, like that actual construction site, because that's how a lot of problems arise, is people do not understand, or they make, even if they're seasoned, they make mistakes and they think that an RFI or a certain location is at another location. If we get to the point where we can get mixed reality to be localized in the right location automatically, that's going to cut out a lot of user error. All right, so jumping into a few proof of concepts that I've created over the years. This is me with the HoloLens on back a couple years ago on a job site in downtown LA. So like I said, I've been doing this for quite a few years and actually going out on site and utilizing this technology. So this is a proof of concept video where we did a proof of concept in a controlled environment. And what you're seeing is actually a bathroom pod that was typically prefabbed and just off site and then flown into the construction site. So the proof of concept was to take that bathroom pod and then break it up step by step and get it into a location where it's repeatable. So if it lost its location, we could turn it back on and get it back in the right location. So this guy's going through and laying the bottom track, and then he's putting up studs and then backing and then the ceiling grid. And he did all this without actually using any construction documentation or tape measures. So, and this was with the HoloLens 1. So it's definitely doable. You know, we did the proof of concept and proved that it's you know, the device is capable of doing this. So it's pretty exciting to think of the opportunities in the near future of what we could potentially do with HoloLens 2. And this is actually, this video is overlaid on top of the track and stud. So it gives you an idea of how accurate that was. We did a side-by-side actually of traditional construction and then mixed reality construction, right? So traditional means of construction with construction documentation, and then the mixed reality, no traditional means as far as, you know, construction documentation and, you know, just coming straight from the BIM model and no tape measure. And we actually did a more of a, well, it was another proof of concept, and I'll share that with you and show you the results. So traditional framing versus augmented framing. So here would be the construction documentation of that bathroom pod. And it's, you know, just going through showing what it looks like in 3D. So this guy was the fastest framer from this company, and we brought him in for this time trial and put a GoPro at multiple angles. You can see this is what he sees, the top track. So there's GoPros at multiple angles, and what we did was had him come in and build a bathroom pod by himself, had a clock going in the background, and had him do it in the traditional means first, and then we had him come in a few months later and did it with a HoloLens mixed reality. And we had those GoPros going then, and then we chopped it up into 5-minute segments. And there's a clock in the background to keep us honest. And it gives you an idea of how the difference, how much quicker he was able to do this. So on the left is augmented reality, on the right is traditional means. So 5 minutes in, he's already on top track with augmented reality, with mixed reality. He's still on bottom track with traditional means 15 minutes in. Already into putting up the studs 20 minutes in, still looking at construction documentation and putting down bottom track and 25 minutes in. So finally, 30 minutes in with traditional means of construction, he's up, putting up top track. He's almost done placing all the studs 35 minutes in with mixed reality. Finally putting up those studs 45 minutes in. 50 minutes in, he's up to, well, actually he's placing the backing 55 minutes in for, and moving on already before an hour in, putting up the ceiling grid with mixed reality construction layout. An hour and 7 minutes in, he's completed his build with mixed reality construction layout. And he's still going over here at an hour and 10 minutes in. So again, we have a clock going on the background, projected in the background there. You can see over in the left-hand side, underlined, hour and 7 minutes in over here. We're gonna be about an hour and 37 minutes in. So, and this is the same guy. He actually tried to best to like go as fast as he could with the traditional means, and you know he's about over 30% faster with mixed reality, and that was the first time he had ever put on mixed reality. So it was his first experience, and you know, we gave him a few minutes to understand what he was looking at, and he had 8 years with traditional means of construction, so that's pretty impressive. He told me that he thought that he could go faster if there was a learning curve and it was improved, which, you know, there's got to be some companies out there doing this by now, right? But right now what I've seen is the majority of this is just model overlay for augmented reality, mixed reality. So there's, you know, definitely exciting new platforms coming out every day. It seems like the technologies are starting to catch up with the dreams that we had 10, 20 years ago. And, you know, it's something exciting to keep tuned and see what's going on. So I'm always sharing on Twitter at Disrupt AEC, on my LinkedIn, Cody Nowak. And again, if you want to reach out to me, you can reach out to me in on those platforms, or you can shoot me an email at cody@thebimcube.com. And with that, I'd like to turn it over to Q&A.